it's not.
Okay, let's get started. So, in terms of all the curves and your web work problems, what we did on Tuesday, so you can do that in recitation today. For those who have recitation, you'll be doing some of that, or help center, or my office hours. So before I forget, your post test. If you haven't taken the post test, you have to do it today. You have to be there by 6:30. Be in the door before 6:30. That is a required element. If you don't take the post test, you will get a 0 on exam 3. So, but if you do take the post test and you improve from the pre-test, you'll earn some bonus on exam 3. Okay, so it's required, and then it'll earn you some bonus points. Then exam number 3 is next week. So you'll want to start studying this weekend so you can get the help you need early next week. Okay, so it's Wednesday or Thursday. So start your studying this weekend. It goes all the way back to, so it's basically, module 6 and 7. 6 was rational functions, and that was the ones that had the vertical asymptotes. So that was a long time ago. You're going to have to go back and review that, relearn it. And then most of module 7. Okay, most of module 7. I'll be posting a review outline like tonight or tomorrow for next week's exam. So you'll definitely want to start studying this week so you can have the chance to get all your questions answered early next week. Any questions about that stuff? Okay, so we should have this down by now. So the function f theta equals sine theta. I want you to, with a partner, explain in detail the meanings of the input and output of that function, which we all should have. We should be very proficient with question number 1. So then given this function f, the second thing would be to explain the meaning of the reverse process of f, or what we talked about, inverse functions, right? So just explain what that process of the inverse of f would be, having answered number 1. Okay, so find a partner, take a minute, and review and answer these questions. Go. So we're talking about sine and its reverse process. So sine, Anna, tell me about the meanings of the input and output of this function f, if it's the sine function.
The input is the angle measures of that counterclockwise from the green hyperposition.
Right.
And the output is the vertical distance above the horizontal diameter.
Well done. Okay, and so we should all, it should be that good. All of you articulating it should be that good. Okay, that quick and that efficient. All right, so number 2. So if those are the input and output of f, then what would the reverse process be? What would the reverse process? Patrick?
Would it take the vertical distance of the horizontal diameter as input and return the angle measured slope counterclockwise from the position?
What do you think about that? Agree? Agree? That's what it would do. It would take now, so now what we're saying is the reverse process would have an input of vertical distance and radius lengths, or which coordinate? We could talk about the input being which coordinate? Y coordinate on a unit circle. And the output would be this angle measure swept counterclockwise from 3 o'clock. Okay, so with that in mind, so now this is the reverse process. So f, okay, so f is still sine. F is the sine function. Okay, so f of x is sine x, just like we talked about. So now I've got some function notation for the reverse or the inverse. So you're going to identify the meaning. So you're looking at this and you're saying, okay, what quantity is that? What does that mean? And then what would this whole expression mean? And then what would its value be? Same thing. What would this 0, what would it represent? What would it mean? And then this whole expression, what would it represent or mean? And find the value. Okay? So do this for these 4. Go.
This is 0, 1, right? Sine. This the y value is 1.
Yeah, so you're
So what's the input and sine?
Yeah, let's do
So what does it represent?
So start at the action. And with 360 degrees, it's full circle. That's 0, right? So y value is 0.
Okay, let's see how we did. Who's our lucky first contestant? How about Tim back there? So when you see this f inverse of 1, what is that 1 referring to? What's that 1 about? Not sure at all? So what did we say? So tell me what the input. No. So what's the input into the sine function? What does it mean? The input into sine. Right. And what's the output? Right. And so now we're talking about the reverse process, okay? So in the reverse process, this is the input in the reverse process. So what would it mean? Would it be angle measure or would it be vertical distance? Vertical distance. So we're talking about a vertical distance of 1. Like that, right? So our input in this first one is saying we're pinpointing a vertical distance or a y coordinate of 1, right? And then what would that whole expression then mean? So what would that whole thing be? Nadine?
Given that the vertical distance above the horizontal diameter is 1,
Right?
they want to know what the angle measure is counterclockwise.
Right. It'd be what that reverse process would give, or its output. And what would it be, Nadine?
For 1, it would be 1.
It'd be what?
Pi, sorry.
She wants pi over 2. What do you think? Okay, how about 0? Christian?
I got 2 pi.
So, let's talk it through. What does the 0 mean?
That's showing a y value of 0.
Okay. So let me show that here. I'm going to show y value of 0. Okay, there you go.
So now you're looking for the angle measure, and you could also have a pi as well.
So you want 0 or pi. So there's more than one angle measure corresponding to a y of 0. Agree? What's that? Audie, what is it? 2 pi. Does 2 pi work?
Yeah, that's what I meant by 0.
Well, but is that the same angle? 0 and 2 pi?
Roughly.
No, it's the same spot on the circle. The totally different angle, right? 0 is no openness. 2 pi is a full rotation of openness. So it's the same spot on the circle, but totally different angle. Totally different. Okay, what about this next one? Negative 1/2. Taz.
So it's saying that the height above the vertical is
That's right.
then it's going to spit out the angle measures subcounterclockwise. So it would be like I forgot, I totally like the only thing.
Yeah, we got. So this is why we did the circle quiz. So is negative 1/2? Is that one of our fourths or one of our sixths? Sixth. So we can count, right? 1, 2, 3, 4, 5, 6. What's it? 7 pi over 6. And we keep counting, and we get another one, right? 8, 9, 10, 11. Okay, so over here in the graph, we're showing, so now in the reverse process, which coordinate is input? If I'm looking at the y equals sine x graph, and I'm thinking about the reverse process, which is my input coordinate? Now y is input, right? So it's like this is input, and then output is the x values that give us that y coordinate, right? And so they're there. This is our. Oh no, sorry, over here. I went into negative territory. Positive territory is here. So that's the input, negative 0.5, and then this is our 7 pi over 6 right here. And then the 11 pi over 6 would be when this comes back around. Can't see it right now. Right there. Okay, so so for input or a vertical distance of negative 1/2, you see there that those are those two angles, 7 pi over 6 and 11 pi over 6, that give you that vertical distance of negative 1/2. Okay, what about pi? So, Alex, what is that pi talking about? What is it about? Right, okay. And what about the whole thing? All right, so what value is it? No clue.
No, I
Why not?
didn't get to that. I mean, you know that your vertical distance above the horizontal is pi.
So in this picture, where would that be? What's this right here?
That's 1.
1, this is a unit circle.
Yeah.
That's 1. So where's pi?
Pi.
Yeah.
That's like 3.0.
So where would it be from here? Up, right here? Yeah, it'd be like up here. So here's 1, 2, 3.
That's a big circle.
All right, so what angle gets us a vertical distance of pi on the unit circle? What do we think? No. It's got to be on the unit circle, right? So when we pick a y coordinate, we're talking about points on the unit circle. right? So here we are. What point on the unit circle do we get? None, right? Doesn't make sense, right? Does not exist. Why? Because what are the possible inputs into the reverse process? What are the possible inputs you could have? Jared Smith. So what are the possible inputs we could put into the reverse process of sine? From what to what?
From
0 to 2 pi would be the possible inputs. Corey, you agree with that? Yeah? Austin, you agree with that? Tell me so. 1 to negative 1. Because what is the quantity that's the input into the reverse process? Vertical distance below the horizontal diameter. What's the least we could have? The least could be negative 1 radius length below. Can't get any lower than that on the circle. And what's the most? 1. So the domain of this reverse process is all possible vertical distances, or y-coordinates, which would be from negative 1 to 1. Okay? So now we got, so when, for 1, say we said that the output of the reverse was pi over 2. Is that it? So here I'm showing that case right there. And I'll line them up here. So input into the reverse process here would be 1, output pi over 2. So input 1, output pi over 2. These other ones we got more than one answer, right? Is there more than one answer for this one?
Yeah.
Christian says yes. Tell me.
-3 pi over 2.
Negative 3 pi over 2. So here I am. If I go negative 3 pi over 2, does that give me a vertical distance of 1 radius length? Yeah. So actually I'm showing that over here. Right there. There's negative 3 pi over 2 right there. What's that, Jaden? Why? Yeah, so there's only one answer in from 0 to 2 pi. But we can have negative angles and we can have angles greater than, more than one rotation. So we can keep going around the circle. And as we do that, what do we see? So here's our input of 1 as a y-coordinate or vertical distance. How many outputs or angle measures correspond to that? Infinite number. So I can just keep. So we can go out on the x-axis as far as we want on the sine curve, and we'll just keep, every time we go around the circle and we get to the top, we're going to have an angle measure whose vertical distance is 1. So for all these, so for a given vertical distance, how many possible angles are there as output to the reverse process? Infinite number, right? Okay, so is this a function? Is this a function? Okay, lots of...
So you flip the input and the output, right?
We're talking about the reverse process of sine.
Okay.
The reverse process of sine. Is it a function?
Yeah.
He says yes.
Yeah.
A function means for every number that you call with your phone, what do you want to get? So for given a number that you put in your phone. Same person every time. Same person every time. That's a functioning phone. So, is this a function? No, because we put in, it's like as bad as you can get, because for every input into this reverse process, how many outputs are there? An infinite number. Not 1, there's an infinite number. So it's like the antithesis of a function, right? Okay. But we want to force it to be a function. So we want to force it to be a function. How do we do that? So what we need then is, given any possible input from negative 1 to 1, right? Any possible y-coordinate from negative 1 to 1, we need to get just one output. We need to get just one angle measure. So here's that stated. So in order for the reverse process of sine to be a function, we need a continuous interval of the angle theta so that every possible value from negative 1 to 1 hits just one angle. Jade?
But you can't do that with like anything in between these two numbers. You get multiple outputs. Like if you go like negative half.
Right. So we just said that any gives multiple outputs. Even one. Right? Even one gives multiple outputs, see? So how can we need to cut down our possible angles into some interval so that you just get one angle for every possible y coordinate that you can pick from -1 to 1. So Fuda, any ideas about that? Alex has a suggestion.
When we're working with regular sine and cosine functions,
Okay.
usually we look at the period, like to kind of determine everything. So maybe we would use that as to kind of constrain it.
Okay, so what about our standard period of sine? Let's try that. So starting here, so I'm going to highlight this, right? So I'm going to highlight as best I can. Whoa.
That was good.
Let's try this again. So there we go. Okay, so what I've highlighted in blue. So let's say we're going to go from 0 to 2 pi. Does it give one angle for every y coordinate that we could pick? Yes or no? Still gives more than one, right? So like if I picked right here at 0.4, you see that there are two angles in the first quadrant and the second quadrant that would give that. And then if I pick, say, -0.8, -0.8, I'm going to get an angle in the third quadrant to here and an angle in the fourth quadrant to here. Doesn't work. Another suggestion. Boston.
We have to measure by the quadrants. We can measure quadrant 1, right? So quadrant 2 find the way.
So I'm not sure what you're suggesting. So we need a range of angles so that every...
You would measure from 0 to pi over 2 by itself, or from pi over 2 to pi, because then it wouldn't
Okay. But if I do, so I heard 0 to pi over 2 and then pi over 2 to pi. So let's try half a period like this.
No, I just meant like, you could measure from 0 to pi over 2,
Okay.
and then independent of that, you measure from pi over 2 to pi.
But those are, but which, so when we put in 0.5, which is it going to be? Is it going to be the first quadrant angle or the second? What's that? Yes, it's still two angles, right? It's still, sometimes you're going to get the first and sometimes the second, so that violates the function. Function has to be every time we put in, say, positive 0.5, it's going to give us one particular angle. Audie.
You need to go from pi over 2 to 3 pi over 2.
Okay, let's try that. So here's pi over 2 to 3 pi over 2. He's saying from pi over 2 to 3, this part right here. So from there, does that give one angle for every vertical height that we can pick from -1 to 1? Yeah, that works. Do you see how that works? Okay, so let's think about this. As a matter of kind of logic or convenience, suppose that input was 0. Maybe I can get it. Let's see. So suppose that input is 0, right there. Is the logical choice for the angle to be pi? So here we are, we're at this vertical height of 0. Is the logical choice then to pick pi as the angle? What would kind of a more logical choice be instead of pi for the angle measure if we're going to pick a horizontal?
180?
No, that's the same angle.
Yeah.
That's the same angle. Pi over 2 isn't at a height of 0. So when the vertical height is 0, it makes sense that the angle should be what? 0, right? 0. So that would be this here. So although this works, it might not be the best choice. Like we could there's another way we could do this. So how is it that we could choose a range of angles such that when our height is 0, we get the angle 0, which is kind of more, it just makes more sense.
Take the other half.
So from what angle to what angle?
3 pi halves, 5.
This was 3 high.
Sorry, negative 5 halves.
So you want to go from here to here. So he's saying take this part of the curve, right here, this. And that way, all these angles when we're in positive territory here for the y-coordinate, we're going to get all these first quadrant angles, right? Which would be the most logical for those. But then to get our negative values, we're talking about angles swept clockwise, right? So those negative angles are angles swept clockwise from 3 o'clock down to negative pi over 2. Does this do it? Does this give us one angle for every height? Yep, and this is what mathematicians have decided to be the convention so that we can make this reverse process a function. That's the point. We want to make this reverse process a function, and we do that by restricting the potential, the angles that can come out from negative pi over 2 to pi over 2. Then we get just one angle for every y-coordinate we could pick. Question? So here's the idea. So the input is the y-coordinate, and the output is the resulting angle. But you're always going to get an angle, but the angle that's the one that's between negative pi over 2 and pi over 2. Yeah?
Why would we want to work with the inverses?
Oh, also we'll do all kinds of examples.
Oh.
Yeah, I'll show you. Yeah. Yeah. So any situation where you know vertical distance or horizontal distance, and you want to know arc length or you want to know angle, so then that's when we need it. Yeah. Okay. So to review to see if you caught on. So this function is called the arc sine or the inverse sine. In order for it to be a function, we have to restrict the output angle measure in this way. If we don't restrict it, we get lots of angles for every vertical height that we pick. Okay, so two different ways you'll see it: arc sine, or this sine with a -1 exponent, like the inverse symbol. Okay, so I want you to review. So for this arc sine function, you write down, this is a little quiz to see if you followed what's going on. What's all possible input values? What's all possible output values for this new function that we're talking about called the inverse sine? Go. All possible inputs, all possible outputs. Okay, Walter, you're up. How about the domain of the inverse sine? From what to what? Was it? -1 to 1. And what kind of values are those again? What do those numbers mean? For the input into the arc sine?
Well, that's the vertical distance.
Vertical distance above the horizontal diameter measured in?
Radius.
Radius lengths, right? These are vertical distances above the horizontal diameter in radii, or radius lengths. Okay? Range. Jonathan, what are all possible values for the range, for the output? What is it?
Pi over 2.
That's just one value. So what are all possible, what's the whole range of values we could get for the output?
Negative pi over 2.
Negative pi over 2? That's still one value.
And 2 pi over 2.
It's the range from negative pi over 2 to pi over 2. It's all in all values in between. And those are what? Those are angle measures. Swept counterclockwise from 3 o'clock. Okay, so let's just take a moment to talk about these negative angles, because that we haven't really done. Everything we've done mostly has been positive angles. So negative angles means you sweep clockwise, okay? And so that's the situation I'm showing here. Okay? So let's just practice a little bit with that. So for instance, what would the arc sine of, without a calculator, what would the arc sine of negative radical 3 over 2 be? So no calculators, put them away. What would the arc sine of negative radical 3 over 2 be? Diana, any idea? Okay, so 11 pi over 6. So, but what that angle is, though, that's an angle that's all the way around like this. So is our angle going to be? Okay, so you got the right idea? So it's this angle right here, which is a negative angle. Is that negative pi over 6? Negative pi over 3. Okay? Because it's going to be the same openness as our angle in the first quadrant that gives us a sine of radical 3 over 2. Doesn't make sense, right? So it's not, the arc sine will not be, what, this 5 pi over 3. So 5 pi over 3 gets us that same spot at the circle, but the arc sine will be the negative equivalent in the fourth quadrant, sweeping clockwise from 3 o'clock. Okay, so what is the arc sine of negative 1? What's the arc sine of negative 1? Con, what's the arc sine of negative 1? What's that? Negative pi over 2, right? So it's going to be this angle swept clockwise from 3 o'clock. Okay, so some practice here. See if we got the hang of it. So I want you to find the following expressions. So all of them are the arc sine of the sine of something, right? So we've got reverse processes. So let's do the first one together. So is the arc sine of 3 pi over 4, is it 3 pi over 4? Yes or no? Well, let's try it out. How would we, if we did this step by step, what would we have to do first? Find the sine of 3 pi over 4, right? So the sine of 3, where is 3 pi over 4? What quadrant? Second quadrant, splits it right in two, right? So here is 3 pi over 4. What's the sine? So do we know our circle? So let's see. Justin, what's the sine of 3 pi over 4? 3 pi over 4, right? Right here. Yep.
No. It'll be positive.
Okay, so radical 3 over 4 breaks it right in half, and those are square root of 2 over 2's, right?
Yes.
So that's positive square root of 2 over 2. So we're going to take square root of 2 over 2 and put it into the arc sine, right? So square root of 2 over 2 is our vertical height. We're going to put that into the arc sine. Do we get 3 pi over 4 when we do that? No. We get the angle that has that y coordinate, maybe right there. Where? In the one that's between negative pi over 2 and pi over 2, right? That's our output. That's our range. Okay? So sine of 3 pi over 4 is radical 3 over 2. Radical 2 over 2. So this is going to be the same as arc sine of. And what angle in the range from negative pi over 2 to pi over 2 has a y coordinate of radical 2 over 2? Pi over 4. Do you see what's going on? Does it make sense? Ask me. So, did I lose you?
It's just kind of hard to like keep up. It's just.
You put the angle in to sine, it's going to give you the y coordinate, which you know is radical 2 over 2. So now we're taking that and putting it into arc sine. Arc sine will always give an angle between negative pi over 2 and pi over 2. So which angle from negative pi over 2 to pi over 2 has a vertical distance of radical 2 over 2? And that's our pi over 4 angle. All right, so you got more practice here. You go across the rows. Go A, B, C, D. Go in that order, okay? No calculator on these. No calculator. Okay, questions? No calculators.
So we would do what is
Okay, any questions in A through E? Just up through E. So I put the answers up. Is that what you got? We're doing A through E, just for now. Any questions on A through E? It makes sense to everybody. You're able to get that? Question, B? So B, sine of 5 pi over 3. So sine of, what quadrant are we in for that? What quadrant is 5 pi over 3 in? It's in the, this is where it is. It's in the fourth quadrant. So 5 pi over 3 takes us to here on the circle. All right? That's the angle for 5 pi over 3. So sine of 5 pi over 3 is radical 3 over 2. It's that y coordinate. So now we're going to take that y coordinate, that vertical distance, and put it into arcsine. And it's going to give us the angle from negative pi over 2 to pi over 2, right? Because that's the range of angles for arcsine. So will it give us a negative or a positive angle? This negative angle right here. Right, like that. So what negative angle is that? If this is 5 pi over 3, then that amount of openness is also pi over 3 right there, right? It's going to be negative pi over 3. Will get us this also this point, and so therefore that y coordinate. Does it make sense? Really? Okay. Any other requests from A through E? Yeah. D. All right. So 7. What quadrant is 7 pi over 6 in? I have to erase. I'm gonna have to erase. What quadrant is 7 pi over 6 in? Which one? No, not 7 pi over 6. It's in 3, right? So 1, 2, 3, 4, 5, 6, 7. Yeah. So 7 pi over 6 is right. Actually, right here. So this is 7 pi over 6. So what is the sine? First of all, what's the sine of 7 pi over 6? Or what's the y coordinate for that angle? Or that vertical distance? What is it? Negative 1/2, right? Here we are at negative 1/2. So now we're going to put that negative 1/2 as a vertical distance into the arcsine, and we're asking what angle from negative pi over 2 to pi over 2 will have that, right? So what will it be? So it's going to be, will it be positive or negative angle? A negative angle, right? It'll be this angle here swept clockwise with that same y coordinate, negative pi over 6. So you really got to know what's going on here. You got to know exactly what arcsine does, right? You know exactly what arcsine does. Okay? So let's look at this one with a 251 degrees. So where is 251 degrees? About? Is that which quadrant? Third quadrant. Is it closer to up here to the top or the bottom of the third quadrant? Bottom. Okay. 251 is closer to, so this is how many degrees here? 180. Bottom of the circle is 270. And here we are at 251. So 251 is going to give us some, the sine is going to, the meaning of the sine will be what? This y coordinate here, or this vertical distance. So as an approximation, let's just approximate it. So sine of 251, what would you approximate it to be? About what, Ahmed? What's that? 0.9? Negative 0.9, or yeah, about negative 0.9 or negative 0.95 or something like that. Okay, so whatever that is, then we're going to take that y coordinate, or that negative 0.9, whatever it is, and we're going to put it into arcsine. And it's going to give us an angle back out, right? Will that be a positive or negative angle? It's going to be negative because it's down there in the fourth quadrant. So here we go. So how are we going to find this negative angle that arcsine is going to give us from there to there? If this whole one is 251, then how much is that? The angle that has the same y coordinate down here. What's that?
Is it 90 degrees minus the difference between 270 and 251?
Okay, something like that. What were we going to say? That just you can do it much more. So go ahead. What was it again? Say it. And then we'll do Joe next. You
Sure,
said,
I was going to take the difference between 270 and 251, which is
okay.
19. And then subtract that from 90 to get the...
Okay, yes, that's exactly right. Okay, so 270 minus 251 is this amount of openness right here. And then he took that amount of openness. He's saying it's the same as this. Take it from 90, and it'll give us this. So you're going to take 90 minus 19 equals 71. So what will it be?
not sure.
No, we just did it. I'm just
Oh, negative.
negative 70. So then we want negative 71. All right, Joe, what was your way? What do you want to do?
I used 180, no, 251 minus 180.
Yep.
This 250.
Right. So here's another way to do it. Look at this. He said you take 251 and subtract 180, and you'll get all this openness, which is exactly what we need here. So 251 minus 180 is 71. So there it is again, negative 71. So now I want you to go now get your calculator, and I want you to put this in. Change your calculator to degrees. In case you think I'm making all this stuff up. Put in, so you're going to do second sine, parentheses, sine of, after you're in degrees, you got to do mode in degrees. Do second sine, and then parentheses, sine 251. And you should get negative 71. Does it work? Okay. So that's what's going on. So this is, you've got to know what's going on here. You can't just, like, for instance, like we said in the very first example, you can't just say this is 3 pi over 4. And this is just, isn't 251, right? No, it's not. It's negative 71. And so when you're using arcsine in your calculator and you're getting these angles, you have to know what you're getting. You have to know what that means. And this is what's happening. This is what your calculator is doing. It's the same process that we did. Okay, any questions on that? On that one, on the 251. Okay, so let's do G. Let's do G. So 2 now, we're back to radian measure. And so now that we've done this, why don't you try G? Take a minute and see if you can do G on your own. No calculator, again, no calculator. And figure out how can we get what is the value of the arcsine of the sine of 2 radians. Okay, see if you can do it. Go. Jared, any progress?
Is it going to be in quadrant 2?
Quadrant 2. Okay, so do you know about where we'll be in quadrant 2? Like more towards the top or more towards the bottom?
A little bit more towards the top.
Okay, right, exactly. So one radius length or 1 radian is about there, and then 2, something closer to the top like this. So this is our, that's 2. Okay, now what? What does it say to do? What are we doing with those 2 radians? What does it say to do with that 2 radians? No, not the inverse. What is it telling us to do? Vertical distance above the horizontal diameter. So whatever that, do we need to know what it is? Just some, that's right there. That is sine of 2, right there. That y coordinate is sine of 2. Where am I going to write it? I'll try here. Sine of 2. It's that vertical distance. Okay, now what? Okay, so it's around 0.8. Cool. Now what are we going to do with that? Right. Exactly. So we want to find an angle in quadrant 1 that has that same y coordinate of sine 2. Hopefully this won't be too ugly here. Something like that. So what angle in quadrant 1, right, like this, that's going to be what the arcsine is going to give us. Any ideas? How are we going to get that angle? Keep going? You know, that's the thing about the key angles. You don't get trapped into thinking there's only 16 angles on the circle, right? So it might be somewhere around there, but no, it relates to 2. It doesn't relate to pi over 3. So how does it relate to the original angle 2? Jade?
You can take 2 radians.
Yeah.
You know that halfway through the circle is pi.
To here?
Yeah.
Okay.
So you can subtract 2 radians and pi radians.
Okay.
And get the amount of openness between those.
So he wants this amount of openness. And how will that relate to the angle that arc sine is going to give us?
Yeah, that's what you're saying.
Same amount of openness. So he's saying this amount of openness right here will be the same as what arc sine will give us. And how do we get that value? What is it? Pi minus 2. Therefore, this is pi minus 2. Okay, so now put in your calculator. Now you got to switch to radians. Switch back to radians. And do this. And what are we expecting? So we know what pi is. If we subtract 2, what should we get? 1.14159. Right? Is that what it gives you? Okay. So when you're using your calculator, you're using that arc sine, you have to understand what it's giving you. That's why we're taking the time to do these problems, because it's not going. Sometimes it won't be what you expect if you're just thinking it's, you know, shouldn't it just be 2, right? Shouldn't it just be 2? No, it's not. It's going to give you the angle between negative pi over 2 and pi over 2 that has that vertical distance and radius lengths that you give it. Question, Alex?
For cosine, would be just the same constraints.
Well, yeah, so it's a little bit different. So let's do some examples with arc sine, and then we'll talk about cosine at the end. Okay, so let's see how this all applies. So here's our ladybug. She's at it again, okay? She's riding on the fan. She is 2.3 feet from the center of the fan. So the ladybug is 2.3 feet from the center. Okay? And she reaches a point that's 1.5 feet below the horizontal diameter for the second time. Okay? So in other words, she started at 3 o'clock position. She's coming around like this. And here's the first time she's 1.5 feet below the horizontal diameter. And then here's the second time. Something like that. So this is the second time she's 1.5 feet below. So let's show that. So her distance below the horizontal diameter is 1.5 feet. Make sense? So the question is, what angle has the ladybug swept out? What angle has the ladybug swept out? Given that she's now 1.5 feet below the horizontal diameter for the second time, or in the fourth quadrant. So I'm showing the angle in red there. That's our goal, is to find that. Is the question clear? Does that make sense?
I didn't quite get it.
Where did I lose you? Okay, she's 2.3 feet from the center. She's going to start rotating. She's going to come around here in the third quadrant. When she gets, so here she goes. Ready? First quadrant, second quadrant. In the third quadrant, there's going to come a point where she's 1.5 feet below that horizontal diameter for the first time. Then when she gets to the fourth quadrant, there's going to be a point when she's 1.5 feet below for the second time. And this is the point we're talking about. When she's 1.5 feet below for the second time in that first rotation. What angle has she swept? What angle has the bug swept out? Okay, so this is a matter of what process. What do we have? We know. What thing do we know? What quantity do we know? Okay, so that's a fixed quantity, but and what's in all the stuff we've been talking about in the last 4 weeks? What is that like? Yeah, output of sine, vertical distance above the horizontal diameter. Okay? And we want what? Angle measure. So what process that we've learned, possibly even recently learned, can get us from vertical distance above horizontal diameter and give us angle? What we did all day in class, arc sine. This is arc sine. Inverse sine. Okay? Arc sine takes a vertical distance, gives angle measure. So we just got to put the right thing in and then be able to interpret the result. So what are we going to put into the arc sine? Are we going to put 1.5 in? Audie, what do you want to put in?
1.5 out of 2.3.
1.5 out of 2.3. Why do you want to do that?
This arc sine works on the domain of -1 to 1.
Okay?
So we're making it a fraction of 1.
Good. So it's in radius lengths, right? So we're making into radius lengths first. Excellent. We got to do radius lengths. Is this right? Alex?
Is it called arc sine because the constraint actually just makes it an arc?
I don't know why it's called arc sine. I don't know where that came from. Sorry. Is this right? Is this going to give us the right thing?
It should.
It's not right.
No, it's going to give you a negative value, like a negative angle, but you want it the rotation after.
I'm asking if this input is correct for this situation. Is this input correct? Why not? Because? Yeah, we're below the horizontal diameter. So we got to input negative. Negative. It's got to be a negative 1.5 over 2.3. Doesn't make sense. Okay, so let's do it in degrees. Okay, so put your in degrees, calculator in degrees. We're going to get an answer here. And how many degrees did you get?
-40.
-40.7. Is that our answer? Are we done? Why did it give us -40.7? What's that about? This is a fourth quadrant angle. It should be more than 270. Patrick.
It's giving us the angle in just the first quadrant, fourth quadrant. Fourth quadrant's called negative angles. So we need to find the opposite of that angle, essentially. Give us the angle that would have been swept out the other way.
Okay, so the opposite of this is 40.7. So that, but you're thinking the right thing. But careful. So opposite means just take it times -1. Okay, what possible numbers could have been our result when we put in something into arc sine? If we're doing degrees, we know we're going to get something between -90 and 90. So what do we get? We got this angle right here that corresponds to this same y coordinate of 1.5 over 2.3. So this is 40.7 swept that way. So how are we going to get the red angle? Fuda. How can we get the angle that we want? 360 minus 40.7. Does it work? Yeah, because if that's 40.7, we're going to take a full rotation, subtract the 40.7, that'll give us this red angle. How much is it? 2. Sorry, 3 what? Thank you. 319.3. Do I have it right? So when you use this arc sine recalculator, you got to know what it's telling you. Got to know what it's telling you. Okay, so what about example number 2, just for you guys? Find the arc length the bug travels when it hits 0.5 feet above the horizontal diameter for the second time. Go. And we still have one more thing to do after this, so work fast. Work efficiently. So find the arc length that the bug travels when it hits 0.5 feet above the horizontal diameter for the second time in the first rotation. So you got to figure out what quadrant is that, first of all. What quadrant does it hit 0.5 feet above the second time, and where will that be? And now I'm asking for arc length. I can show you that too. So it's maybe something like that. Now I want to know this arc length. I want to know this arc length right here. So, can you get me started? Jared Smith, can you get me started on this? Of 0.5. So what does the input into arc sine mean again? In radius lengths. Is this radius lengths? 0.5? Feet. So if you're 0.5 feet above, how many radius lengths above are you? Or give me the expression, not the final. Divide by what? 2.3. That's our radius lengths, right? So it's what fraction of 2.3? We need the fraction of 2.3 that 0.5 is. Positive or negative? Because? Above. Okay? So this is going to give us .219. We really got to understand what that number is in this situation. Who can explain what does that number mean in this situation? Yeah, Christian.
It's the amount of radius lengths that 0.5 feet is covered in the y value while the arc length. Yeah, it's the amount of radius lengths covered by 0.5.
This is the number of radius lengths from here to here. It's 0.219.
No, in the y value, it's 0.5 feet. On the other side, I'm talking about it on the first
On
quadrant.
the other side.
Yeah, it's right there.
Okay,
So
so
it's 0.219 radius.
like this.
Yeah.
So he's saying that over here, this angle over here is 0.219 radians. So that arc that I highlighted is 0.219 radius lengths. Agree? Okay. Now what? Sure.
All right, and then I took pi
Pi?
minus that amount of radius lengths to see the difference of how much it would be from 0 to that point.
Right?
And then I multiplied that by the actual radius.
Excellent. So this then would be our arc length and radius lengths, right? Or the angle measure in radians. Pi minus 0.219 would be our angle measure in radians. And if we want now the arc length, how are we going to get the arc length in feet? We're going to take that number of radians and do what? That's also not only radians, but radius lengths. So we take every radius is 2.3 feet. So that will give us how far the bug has traveled in feet. 2.3 times pi minus 0.219. Questions on that problem? Okay, it's 30 seconds. I got to show you something. You can quietly pack up if you want. Arc cosine. Ready? Quietly. Listen. Arc cosine input will be what? Horizontal distance from vertical diameter in arc cosine, and output will be angle measure. So to make it a function, we need what? We need one range of angles, or we need a range of angles so that we get one angle for every x coordinate, for every horizontal distance. So what range of angles will do that? Watch it and burn it in your mind. Ready? Maybe? 0 to pi gives you one angle for every x coordinate that you could pick. So when you use arc cosine in your calculator, you're going to get the equivalent angle between 0 and pi. So if you're working in the third or fourth quadrant, you got to make the adjustment, like we've been doing. Have a great weekend. Look, if you didn't take the post test, you got to be in there today by 6:30. Exam 3 next week. What's that? Post test. Just show up in your question center, just like all the rest. Don't study, just do your best. By today at 6:30, yep. I sent an email out. Did you get my email? So I definitely want you to maybe do the pendulum problem from the, I think it's number 2 in the web work. The one that was due today? Yep. So the pendulum problem and then the tide problem from the web work. Definitely work through those. And then if you still have time, you can do at the second half of investigation 9 is where the applications of arc sine and cosine start. So work on those. So they give you like a situation with, like I just did.
Am I still studying?
And yes, I'm going to give you a lesson plan. So it'll be sine and cosine trig triangles. Is that good? Okay, cool. See ya.